Okay, not really sure if this is going to work or not. This is really kind of weird talking to myself. Uh, Hold on a second. I can hear myself on this thing. Here we go. So I'm just going to show you a little bit about this thing called Matlab that I've been working with a lot. I've been able to do a lot of really interesting things with it. Some of the more elaborate things I've done, I can show you in this. This is the code I wrote to work with all the data I took with my pendulum, all the videos and things like that. I have all kinds of things. I just have variables I define, separating the data. I have to fight the data I took was just a bunch of positions of the two pendulums. All this just tells me the angles based on those positions. Then I have some other things that are more technical. And this plots a bunch of figures and saves them as files to my computer. That's one example. I won't show you that because it's not really all that visually interesting. Something more interesting is this. This is a little program I wrote that that creates a little figure. I'm actually gonna, or that simulates a little projectile motion thing. I'm actually gonna I'll show you that really quick. I think it's kind of neat. So here I have initial velocity of 20 meters per second. Let's say that the initial angle of trajectory is pi over 4. It's 45 degrees. I'm just going to make the thing start at 0, 0. Let's see if it shows up. Where is it? Oh no. There we go. Ah, here we go. So there it is, and there it goes. And so that's kind of neat. A little projectile, and I can do different things with it. And I can also try running it, and I can change the, oops, that's all right. I can change the initial position to something like that, and then we'll go like that. So that's less exciting, but it's pretty cool. And then that's not even the most interesting thing I can do with it. Actually, if I find my downloads here, let's see here. I have some what are called initial conditions for the two-dimensional wave equation, which is a really cool thing. I'll show you here. Wave 2D. So now I have R2D. So now I have x1, y1, u1c, 0 times u1c, c, t, and n. So I'll make that 10 just to make it run a little more smoothly. So it comes up with something like this. This is a 3D figure of a wave. See, it's three-dimensional, and when I hit enter, there it goes. It's pretty cool. And I'll just keep going. I'll get crazier and crazier as it goes on. I can go ahead and stop that. I can try another one. These are all, I have all kinds of, I have a bunch of different sort of initial conditions that I can try. These were, I didn't write these initial conditions. These were provided by my professor. And I can go again. Oop. There it is. So yeah, it's like the surface of a little pond. And then what I have here is these are called fixed boundary conditions. Because you can see along the edges don't change. The edges are always at 0. And I can actually change the function itself, a couple aspects of the function itself, to make the ends free, which means that the ends will go up and down, and it'll be more like a swimming pool rather than a swimming pool that's restricted. I think this will work. Let's see. There we go. Let's see how now it's going all wobbly and crazy. This is one of my favorite things that I've done in Matlab. This 2D wave equation. I also have a one-dimensional wave equation, which is just kind of a single. It's less interesting. It's just a single line. It's just a wave that'll go back and forth. This is a lot cooler. And there are some other really neat things I can do with this too. Some things that are kind of more kooky and entertaining. For example, in this one, this plots what's called Laplace's equation. It's just another one of those equations. Like the wave equation is what's called a partial differential equation, and Laplace's equation is just a different one. And these can be used to describe a bunch of different things. Then I can say n, then it goes woo. That doesn't. I mean, changing the codes like that doesn't really serve any purpose, but I think it's pretty cool and entertaining. Look at just what that looks like. And all these things I wrote myself. You know, these I wrote each and every one of these lines to make it do exactly what I wanted. But Matlab is a lot more than that. It does all kinds of things. You know, I can just do simple math. 5 plus 5 is 10. You know, I can make a new figure, and I can make some new function. Let's see here. I don't know what's going on here. Gotta change the batteries on my keyboard. It's been acting up on me lately. So, let's say plot xf. Let's see here. I get a nice little sine wave, or at least part of a sine wave. And that's just a few of the things I can do. To give you a quick taste of my pendulum program, what my pendulum thing does. First of all, I want to clear all the variables, bring in, this is all the data I took for the pendulum over here. Each of these numbers here in this first slot tells me how many data points there are in each one, and each of these sets corresponds to a particular video. And there are 46 of these. So there are tens of thousands of data points, and I wrote a program to go through each and every one of them. One of my favorite figures that this thing can create is the figure that just shows what are the positions of the two pendulums, and that's pretty cool. Let me just here comment this part out too. Commenting out just makes the function just ignore it. Change that, and then I'll just say pendulum. What would it be? I second 90. This is a video where the initial angle of the pendulum was 90 degrees. I'll show a video of that in just a second because it's kind of neat. I think. Here we go. So this is the actual plot, a three-dimensional plot of the position of the two different pendulums. the blue one is the larger pendulum that's on the inside, and the green one is a smaller pendulum because that one sort of goes all over the place. And I can look at it, from the sides, things like that. I can see how towards the end I get a nice little wavy thing. But this one was an example of something that's really chaotic, and so it's all over the place, and you can't really see anything in particular. Then, to show, just because I like it, to show you some of footage that I actually took, the actual raw footage I took of my pendulum, just to show you what it looked like and then how I did it. There's a pendulum that's pretty pixelated, but it's kind of cool anyway. So there it goes, spinning all around. And actually, I had this other program that I mentioned in my last blog, this Image J, that it tracks these two white dots here and here, and gives me the positions of each of them. And I just put all that data in here and then ran it through this program, and I got all of my pretty figures. I have all kinds of figures. Let me show you really quick. Let's see here, where would it be? I think it might be over this way. Yeah. If I just open some of these, I'm going to show you. I made hundreds and hundreds of figures with this one program. It just went through each set of data. This is the angles of the two pendulums versus time. This is the angle, and this is time. And just shows, just sort of shows you some of the data that I took for this project. You can see some of it's very complicated. That's a very chaotic one. That's a very stable one. So yeah, so that's Matlab, and that's a taste of the project I worked on and that I completed, and that I'm currently writing the paper for. So I hope this actually worked, and I'll see you guys later.